this is your presenter Asloob Mudassar, and I am presenting slide number 5 of the course on laser physics. Question number 5. Write down the decay rate equations for the three processes, that is the radiative, which we call spontaneous decay, non-radiative, and stimulated emission decay rates. So we have to write down the decay rates of these three processes. Answer. Lasing action, which results in the emission of laser light, occurs between two specific levels in the particles of the active medium called upper and lower laser levels. Normally, the upper level has a smaller population than the lower level. For lasing processes, or for the lasing process, the population of the upper level must be greater than the lower level. That is the population in the lower level, which is known as the population inversion. Let Ni is the population per unit volume of the ith level. Then the rate of decay of the population of the second level, considering two-level laser system, will be proportional to the population of that level for all the three processes. That is dN2 over dt, that is the rate of change of the population in the level 2, is proportional to minus times the population in that level. This negative sign means that we are talking about the rate of decay. So dN over d2, dN2 over d2, due to this negative sign, means that the rate of decay of the population in level 2 is proportional to the population in that level. The equation for the rate of decay of the three processes can now be given using by converting the proportionality sign into the equality sign for the three processes. For example, dN2 over dt for the spontaneous emission process is equal to minus N2 over tau Sp. Sp stands for the spontaneous emission process. And then we have, which is given in equation number 5.1, and then we have dN2 over dt for the non-radiative decay is equal to minus N2 over tau Nr. This tau Nr is actually for the non-radiative decay. And this is in equation number 5.2. Then we have equation number 5.3, which gives dN2 over dt for the stimulated emission is equal to minus N2 over tau St. St stands for the stimulated emission. Sp stands for the spontaneous, Nr stands for the non-radiative, St stands for the stimulated, and tau is the emission lifetime, or simply the lifetime of the excited state. Tau Nr is affected by the surrounding medium. A denser medium means more chances of collision and smaller lifetime of the level. Tau St is affected by the intensity of the incident electromagnetic wave. A more intense beam means higher chances of stimulated emission and smaller lifetime of the level. The rate equations for the spontaneous and stimulated emissions are usually expressed using Einstein's coefficients as given below. For example, dN2 over dt for the spontaneous emission is equal to minus A times N2 as given in equation number 5.4, and then we have dN2 over dt for the stimulated emission is equal to minus W21 times N2. When a plane wave of photon flux F illuminates excited particles in the active medium, then some of the excited particles will decay through stimulated emission with a cross section, say sigma 2,1. Then the stimulated emission decay rate is given by W21 is equal to sigma 2,1 times F. So you see that F is the photon flux of the incident beam, and W21 is actually the photon flux of the photons emitted through the stimulated emission, and sigma 21 is the cross section that decides the number, or that decides the number. And then you see that W21, which simply means that the number that the photon flux of this emitted in the stimulated emission process. So you see that these are the rate of equations for the three processes, and then we have combined these, then we have written these rate of equations using the Einstein's coefficients. More detail will be presented in next slides. So this is the end of slide number 5.